How's it going, everyone? We are Team 1, the G-Bots. My name is Robert Shaw. I'm with Derek Sack, Raul, and Saphir. And we're going to talk to you today about our planning report and what we're doing to make designs for our robot and come up with a final design. So as you all know from the problem understanding and all the papers and presentations we've had, is that we have a 7x7 board and we have a certain starting volume that we need to meet. And we have to complete tasks on this board. And I'm going to go a little bit more in depth when I go into our house of quality. So in our house of quality, we have customer requirements, and the customers are us. So we're trying to make good decisions for ourselves and make our engineering requirements and customer requirements fit our needs for this project. So as you can see, our three highest customer requirements are high scoring, autonomous, and we want it to be safe for whoever uses it. So high scoring, we want to score as many points and move on to competition. And autonomous, we have to have it autonomous or we can't compete in the competition. And we want it to be safe. We want to be able to use it as many times as we can. So, and then our three top engineering requirements are rate of disqualification, average time to retrieve tennis balls, and minimum time to set up. I'm going to go into minimum time to set up. We want it to be quick and easy to set up so that we don't have as many tasks to complete and we don't miss anything. So now I'm going to pass it off to Derek to talk more about our planning tools and talk more in depth about how we use them and how our team's going to use them in the future.
Yeah, thanks, Robert. And I have the planning tools here for us. And first is the planning tree. So as you can see, some of the main parts of this are to understand tasks, study previous designs, develop concepts, produce prototype, and finalize design. So that is the middle part of this tree, sort of as like an overarching step or steps. And then to the right we have more in detail. And the Gantt chart directly relates to the planning tree, as it takes that first column is what we spoke about earlier. And basically all it does is puts these tasks to a schedule. It makes them a little more in detail, and it puts them on a schedule for each week and what we need to complete. So next, for the job prioritization matrix, these are just where we take some tasks that we need to complete and prioritize them. So two of the most important ones for us were make parts for subsystems and code mechatronics for robot functions. And lastly, directly related to the job priority matrix is the job responsibility matrix. And what this is it just assigns these tasks to the people in the group so that everyone knows what they're doing throughout the project. And we did something different. We added multiple primaries for some tasks because we felt like it was important for everyone to be involved in some of those tasks.
So Derek has discussed the steps to building the robot, as well as providing a timeline and priorities. Now it's time to look at the robot itself. The table on the right is a specification sheet for the device, and the red boxes highlight certain quantities in the sheet that the robot must follow. These quantities may come from different sources, such as competition guidelines, where the robot must occupy a volume of 2 foot by 1.5 foot by 1 foot and start in a 30-inch by 30-inch operating area. The task that the robot completes lies within a triangular area of a 7-foot base and 3.5 foot height. The design team, on the other hand, requires itself to set up the robot in 45 seconds. And the house of quality features an expected point score of 49 points calculated from the sum of expected values for point allocations in each individual task. The function tree shows the tasks that the robot must perform. For example, it must put ping pong balls in the red zone by getting to the center, identifying the red zone, and releasing the ping pong balls. It must also retrieve a doll by identifying a barrier drop, moving to and from the doll in order to attain it. These functions create a basis for the morphological chart describing how to complete those functions. For example, a few solutions to retrieving the tennis ball are an impact wedge that extends out and rakes in the balls, extending an arm out and using a motor to pull the balls back in, and controlling an extended arm to expand and contract via an actuator.
So as y'all can see here, we have our dog bone pusher pictures, and it's mainly just to give you an idea of what we're doing. And on this second slide, you can see what we're doing for our tennis ball retriever. We're just simply throwing an arm out and pulling it back a little bit. And so finally, in conclusion, I want to hit our next steps. You've heard about our problem understanding, our project planning, and our concept development. As for next steps, we have to continue building our robot, continue building these systems so that we can have a reliable robot. We have to test for this reliability and our competitive scoring, and finally we want to test for a disqualification rate, as this is one of our highest priorities. Thank you for your time, and we will take any questions at this time.